Okay, in this video I'm going to start talking about the BC free response question from 2009, Form B, question number 6. And we're given that the function f is defined by the power series f of x is equal to 1 plus x plus 1 plus x plus 1 squared, etc. for all real numbers x for which the series converges. Now this is a similar series to one of our big 7, and that would be 1 over 1 minus x, which turns out to be 1 plus x squared plus x to the third plus x to the fourth, etc. And the general term is x to the nth power. So if 1 over 1 minus x, or if 1 plus x squared, etc., is the Maclaurin series for 1 over 1 minus x, then what we have above is the Taylor series. It should be the Taylor series that is centered at x equals negative 1, and it should simplify to, or it should converge to, negative 1 over x for all real numbers x on which the series converges. So the one above is the Maclaurin series centered at 0, and the one below is a Taylor series centered at x equals negative 1. Aside from that, these are really both the same series. Alright, so you didn't necessarily have to know all that, but these are things that may become important within the problem, and we'll take a look at what we're asked for in Part A next. And Part A asks us to find the interval of convergence of the power series for f, and to justify your answer. Well, one thing that you should note about this function is that it most definitely is a geometric series, where a is equal to 1 and r is equal to x plus 1. So finding the interval of convergence using the fact that this is a geometric series is pretty straightforward. I'm going to find it in two different ways just so that you get a feel for what's happening. Alright, so if this is a geometric series, we're looking for the interval of convergence. We know that a geometric series will converge wherever the absolute value of r is less than 1. And so since r in this case is x plus 1, we're looking for where the absolute value of x plus 1 is less than 1. And so when we have an absolute value inequality where it's a less than, we set up negative 1 is less than x plus 1 is less than 1. We're going to add 1 to both sides. Subtract 1 from both sides. And that gives me my interval of convergence. Whenever x is between negative 2 and 0, not inclusive, then the r in the geometric series, absolute value of r, will be less than 1, and the geometric series will converge. Now another way that we could have gone about this is using the ratio test, which we would normally use if we didn't have a geometric series. And with the ratio test, we're looking at the limit as n goes to infinity of the absolute value of the n plus first term over the nth term. And so that would just be the limit as n approaches infinity of the absolute value of quantity x plus 1 to the n plus 1 over x plus 1 quantity to the nth power. And we can see that simplifying that, we're just going to get absolute value of x plus 1. And from the conclusion or the results of the ratio test, we know that if the absolute value of x plus 1 is less than 1, then the series will converge. If the absolute value of x plus 1 is greater than 1, then that series will diverge. And if the absolute value of x plus 1 is equal to 1, then the test is inconclusive. So if we want to find out where this converges, we just set the absolute value of x plus 1 to be less than 1 and solve for x, which we just did on the right side, so I won't do that again. And so we can see here that the interval of convergence is going to be from x is negative 2 to x equals 0. And that's exactly what we found using the geometric series test. So we could have done this one either way. Normally, if it's not a geometric series, we will always use the ratio test.